Oh, hello everyone. A very warm welcome to all of you. We're coming to you live from three different platforms, X, YouTube, and LinkedIn. Drop us a line from wherever you're actually hailing in, how you're actually joining us. It's always very heartwarming to actually hear people who are joining us from across the lands and across the ocean. So do drop in a line to say hello. And joining with me today are my esteemed speakers from the MLflow team, as well as a new contributor and a new maintainer from Red Hat, Matt Prowl. So guys, say hello to the community and thank you all for joining us. Tombo, you want to say hello to them? Samraj, Yuki?
Hello.
Okay, brilliant. Well, thank you all for joining us. Delighted to be here. Now, some logistics before we actually get into the meat of the matter today, because we have a packed agenda, so we want to go through it quite quickly. A lot of great features that we actually have released for 3.10, so I want you guys to have the best of it and go take a look at it and let us know what you think about it. We always appreciate and admire the features that the feedback that we actually get from the community. Now, some logistics, we can't hear you because of the fact that this is sort of a one-way broadcast, unfortunately, because of the nature of the live stream. However, keep your questions coming. We will reserve the last 15 or 10 minutes for Q&A. So the form and the format is going to be, we're going to have, all the four speakers go one after the other, and we'll reserve questions at the end. So keep your questions coming in the chat, and that would be sort of a good way to get started. Okay, today's agenda, this is how we're going to start. We're going to have first talk from Yuki, who's going to tell us about what MLflow experiment is all about. What is this particular new feature that allows you to somehow play around with it? So he'll give us a good look into it, why you should use it, and how you can actually use it, and how you can show it off to some of your friends who actually are new to MLflow. And then we'll transition to MA Gateway for user tracking. Governance is an important part of it, and this is a good gateway for you to sort of keep control on who's doing what and how they're actually using. So Tomo is going to share that with us in how you can actually exercise control through gateway using governance. And then we'll go into this new particular feature that Matt from Red Hat has actually contributed. So he's going to talk about what MLflow Workspaces is all about, how you can actually isolate your particular environment. And that also introduces in some sort of a way how you can actually isolate and do governance at the same time. And then finally, last but not least, I think is an important part. We have been investing heavily in how to actually do multi-turn evaluation. We started first in 3.9. We published quite a blogs, a very interesting blog that actually talks about how you can actually do incessant evaluations with existing MLflow integrations, both built-in judges as well as the new ones. And we have taken this one step forward by actually doing some sort of a simulation. So you can actually do a pretty rigorous simulation of conversations as you go on. So Samraj is going to give us a down on that one, and that will end up with Q&A. Now, just a couple of things which are coming up. We will really participate. We really enjoy interacting with the community. So if you are new to this, please do join us. There are various mechanisms by which you can actually join us, various channels. You can join us a Slack channel. If you are a contributor or if you have some issues, do join us. Give us a star on GitHub as well if you actually like what you actually see today. GitHub is a good way to discuss and file issues and also file PRs. We love contributions. We love you to expand and extend the functionality and the feature functionality of MLflow. And then we also have a LinkedIn channel, pages where we keep up to date about the blogs and all the great content that the community actually shares with us. It will be amplified with that as well as on Twitter. And then on Luma, we have all the events such as this one that you can actually find out if you've actually missed. And finally, if you are going to be in San Francisco during the month of June through the 18th, we have a very special Data Plus AI Summit, which is a global gathering of people who are interested in both data engineering and also in AI. So this is going to be a good way to meet the community at large, and there are going to be a lot of good talks on AI and MLflow. So if you're here, do come in. With that, I think I'm going to hand it off to Yuki to give us a good insight into the MLflow demo experiment. So take it away, Yuki. Thank you for joining us.
Sure. Thanks for the great interaction, Jules. I'm Yuki. I'm an engineer in MLflow team, and yeah, I've been here in this meetup for maybe 3 or 4 times, so you guys might know my face. But today, what I'm going to introduce is MLflow demo experiment. Okay, so starting from the problem, as always. So you might be using MLflow for years, or you might have been using MLflow for a month, or just new to MLflow, to just curious to like, hey, what is MLflow doing? And here's a list of features MLflow shipped in last 12 months, only major features. So agent evaluation, session view for tracing, cost tracking, dashboard, the summary use of true usage, human feedback, annotation gateway, distributed trading, blah, 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 blah. So luckily, we have a very great builders in the team, but as a result, so we are shipping a lot of features, and sometimes we have heard that like, hey, it's very hard to catch up with MLflow. We release minor version like 3.10, 3.9 every month, and every release have like 4 or 5 features, major features at least. So, and of course, the MLflow is not only your job, right? So your job is actually building agent, you're building ML. So MLflow is just one of the tools. So it's very hard for people to like catch up with all those features, and especially when you're working on so if you have a like actual real project, you need to spend your time. Like you cannot spend like 2 or 3 hours every day for MLflow to catch up those features. Then there is many ways to learn things, right? So for example, documentation is probably the primary way for people to know about big features or things, and it has a good depth. Documentation has a very good detail of each feature, but it's not interactive. So you just read. It's very passive experience. You read how the feature works, how it is, but you cannot learn using action. And there are videos, and many community people in MLflow publishes great tutorial videos and some like recording of the experience of feature, which is great. Then for viewer side, it is low effort. We can just watch video while running or doing gym or doing like laundry, but it's also passive, so you cannot interact with content inside the video. And also it's kind of slow. So videos often have like 10 minutes, 12 minutes for one content. So it's not very like fast learning. And then here's tutorials. So we have like end-to-end tutorials. Hey, here's how to do things in MLflow. This is great. Tutorials always gives us great insight about the feature and like great actually actionable like experience. But it takes time. So if you need to actually sit on the laptop and start tutorials, and probably takes 1 or 2 times to 2 hours to complete the journey. Also, tutorials often focus on the one aspect, one feature. So it's not like holistic view of how MLflow works. And lastly, using action. So bravely adapt it into your actual real project, which is awesome. But it requires like big investment. So you actually need to bet on this feature and adapt into a real project. So if you don't like a feature, you might just waste your time. So these are the reason why we come to this solution, which is MLflow demo experiment. So in MLflow, now we have a demo experiment, which is one-click experience to generate the basically example data of most of the MLflow features and let you interact with all of those features in MLflow UI directly. And it's easier to show than explain in words. So let me just start the demo of the demo. So, yep. So here's cool. So here's the MLflow UI, right? So if you upgrade to 3.10 and log into MLflow, you will see this UI. And this is a completely like a new server, so you only have a default experiment. Then we have this new big banner here. And if you click on this start demo, it loads in a 2 or 3 seconds, but okay, here you go. So here's a demo experiment. So you're already in demo experiment, and this is the dashboard view we are adding. And here, so you can see the 33 traces are generated in the demo. And all the data like latency, the token counts, the cost breakdowns already pre-computed. So you can see like, oh, okay, so here's a cost breakdown feature. And yeah, you can break down by model, and okay, so there's no provider, but and here's the latency graphs. And we have quality metrics pre-computed as well. So you can see how the quality graph looks like. And tool call summary is there. So you can see like if you are a actual developer, agent developer, and if you start using MLflow with tracing, you will see this kind of like tool breakdown in the graph in a nice way. And so you can interact with, so all of these are interactive. So you can click on the, for example, this graph to view traces in this period. So you can jump to the trace view, you can open trace, look over what is in trace, and you can see the feedbacks, or you can even add your feedback, because this is just a normal experiment. And of course, this is not about traces. So you can go to session view, you can go to judges, dataset, evaluation runs. So some of the features are actually like what we're gonna talk in this video in the most fun part. So I'm gonna be a bit of spoiler, but for example, you can see how session evaluation works in action without setting up actual evaluation like dataset or script by yourself. And of course, we have prompt, and yeah, you can also compare the prompt version here. So lots of features are available in this demo experiment. So with this, you can, so whenever you see the MLflow release, then for example, next 3.11, you can upgrade the MLflow server. It doesn't need to be the real server. You can create a like temporary server to do demo. And then you can click on this like generate demo button, and then go to, so can find whatever feature release here. So yeah, it's my part is short, but that's it. And from here, other people in the team will introduce a lot of cool new features. So please install MLflow and try play around with those in this demo experiment. And yeah, then I'm gonna hand over to Tom for gateway part.
Sure. Thank you, Yuki.
Thank you, Yuki, for the turn of the phrase. I really like demo of the demo. I like that. All right, that was a good one. All right, Tomu, tell us all about Gateway and how you're going to govern and how it actually helps to do all the good stuff that the name Gateway stands for, control.
Yeah, thank you, Zero. Okay, hi everyone. I'm Tom Hietar. I'm a maintainer of ML4. Today I'm going to talk about the AI gateway of ML4. And as Yuki did, let me start with the motivation and reasons for why we need to use AI gateway. So there's like several aspects. First of all, you want to get a unified endpoint for using different providers and language models. As you may know, different providers like OpenAI, Anthropic, Gemini provide their LM and API through a different interface. So if you want to try out different providers or models, then you may need to change the client code, or you may need to switch the client SDK, which is not really easy. Of course, there's like several solutions for the client side to switch across multiple providers, but it's easier if you can unify the interface on the server side. So this is like one motivation. The another motivation is like if your team or organization gets bigger, then you may want to control their permission to each provider or model. So as a admin or director of the engineering organization, I want to control which team has access to which model. This kind of motivation. So we call it governance, and then this is another motivation for using AI gateway. Then last motivation is observability. Let's say, okay, like you can control the permission and you can have a unified endpoint, but at the end of the day, you want to know, how much it costs for using language model from your organization or team. I think you may want to know, you may want to track like each, request and response for your language model usage. So this is aspect of observability, and this is also an important part of important motivation for using AI gateway. Okay, let me move on. So that's why we provide ML for AI gateway. Actually, we started to ship this feature from the last release, 3.9. But like with 3.10, we have enhanced the AI gateway capability, especially for the observability part. So yeah, I thought like, this is a good time for me to like explain this feature for the community. So we provide AI gateway on the exact server you use for, tracing or eval. So you don't need to set up another server or another process to spin up the AI gateway server. You can just continue to use the tracking server you use every day to actually unify the endpoint and get a visibility for your AI usage. Then so I think this is a unique aspect of ML for AI gateway. Unlike other gateway, like solutions, you don't need to prepare ML ops tool and AI gateway tool separately. You can just have one tool, MLflow, for doing the ML ops and also AI gateway together. So with ML4 AI gateway, you can get permission control. Some of this feature in this figure might not be included in the recent release, but this is something we're gonna ship. You can control the permission of each endpoint or each access to their language model or provider. You can set a rate limit or budget limit. You can have guardrails, and we have a traffic routing, so your traffic will be routed to some of the underlying language models, and we also have a fallback, so you can enhance the reliability of your endpoint. Then like you can enable the usage tracking, which has shipped in 3.10. So now you can see the the usage data of your AI, ML4 AI gateway as ML4 traces. I will explain it later. And because like we track the AI gateway logs as ML4 tracing, you can use these logs for any other features of existing feature of ML4, like evaluation or like optimization if you want to. So let me start with fundamental functionality. So for the providers, ML4 supports a wide range of providers, as described in this slide. We support OpenAI, Anthropic, and Gemini, and so on. We provide two types of endpoints. One is unified endpoint. As I mentioned, you can use any providers with a single interface, which is OpenAI compatible. We also provide passive endpoints because these endpoints basically relay all their payloads to their underlying provider server. This passive endpoints is also important because you can get immediate full access to their provider specific features, which is not available in the unified endpoints. So we provide this kind of these two type of endpoints to support a wide range of use cases. Then we have traffic routing. As I mentioned, there's a way to randomly split the traffic. This is for load balancing or A/B testing, and you can also configure the fallback model. So you can you can set up multiple models for the same endpoint so that at the time of outage or quota limit, you can use the fallback model to enhance the reliability. Then now we ship the usage tracking, so you can get the usage dashboard out of box. You can see request volume, latency, error rate, token usage, dollar usage, and so on this dashboard to get our observability for your AI gateway usage. And as I mentioned, these data are stored as ML4 tracing, so you can use it for like downstream work like evaluation and optimization. Okay, let me do some demo. Let me switch over to my screen. Oh, thank you so much. So let me just walk through the fundamental aspect of AI Gateway. So now, so here in the left tab, under JAI, you can find AI Gateway tab. In the sidebar, there's a button for creating an endpoint. So I can just, sorry. So I can create this endpoint. I will select OpenAI. Then you can see this nice view for selecting models. I will select GPT-5 Nano just for cost. Instead of using my new API key, I will use the existing API key. So yeah, this is also a good functionality of MLflow AI Gateway. You can register your API key and you can use it across multiple endpoints. Create endpoints. Once you create our endpoints, you can find the example usage of AI Gateway endpoints. So as I mentioned, there's a unified APIs. There's also a pass-through APIs. We provide car example, and also we provide the Python example, so you can just copy and paste and run it. Then once you use the endpoint like this, you can see the usage. You can see the usage chart under endpoint detail page. You can see the request volume. You can see latency, error rate, token usage, and cost breakdown. And not only for our single endpoint, we have a dashboard for analyzing the usage across multiple endpoints. So in this dashboard, you can see the total volume of request for the entire AI gateway usage. You can see latency again, error rate, token usage, and you can also see the cost breakdown per model or per provider, so you can know, how much you spend for which provider. And also you can see the cost breakdown over time. So you can also detect the, jump of the usage like this. So these are the features that we provide in MLflow 3.10. As I mentioned, we plan to provide more features for AI Gateway, so stay tuned. And that's all from my side. Thank you so much.
Thank you, Tomo. That was a good way to share with the community how you can actually exercise some control over who's using what, where, and when. I'm sure we'll have some questions on that momentarily. Next, we're gonna hear from Matt.
Hi.
Take it away, Matt.
Yeah, thanks. I'm Matt Prail. I'm a new MLflow maintainer, also a Kubeflow pipelines maintainer, and I work at Red Hat. And today I'll be talking about the MLflow Workspace feature that was added in MLflow 3.10. So prior to workspaces, the highest level of grouping mechanisms there were experiments, registered models, prompts, now gateways. But workspaces adds a layer above this. So that way you can have logical isolation between different work streams, projects, different teams. So you can define a workspace, say workspace A for a particular team. Experiments, registered models are tied to that workspace. But you can also have workspace B that has its own set of experiments, registered models, etc. And it has flexible access controls where I can assign user permissions at the workspace level, or I can continue using the granular controls that exist today, like assigning a permission directly on an experiment. So there's the flexibility of both. So we talked about experiments, but where do the artifacts get stored when workspaces are enabled? So the default artifact root that's set at the server will be used, and there's a suffix that gets appended to it of /workspaces/workspace name. This is what gets assigned by default to every new workspace you create for all experiment artifact locations. But an admin can override the default at the workspace level. So when you go to create a workspace or update it later, you can override it to say this workspace uses this S3 bucket for artifact storage location, or you can choose to keep it on the default. In this mode, though, you can't set artifact location at the experiment level, just to protect the workspace isolation on this single instance. We want it to be in admin control. Similarly, when MLflow is serving artifacts, workspaces are assigned a dedicated path, as you can see there. As part of the design process and development, backwards compatibility was really a top focus. So if you don't enable workspaces on your MLflow instance, nothing's changed. It interacts and works the same exact way as it did before. But if you enable workspaces, then all of the existing experiments, registered models, prompts, etc., get assigned to a default workspace. And this is literally just the name default, which I'll show in the demo. And if you have existing MLflow instrumented code, it'll continue to work, because if you don't provide a workspace, it will default to the default workspace. Though there is a configuration option if you're using basic auth that's available in MLflow. There's a configuration option to grant access to the default workspace. This is off by default, just so that new installs have no permissions assigned to users. So I'll be switching over to the live demo, which I'll be showing how to enable workspaces, go over the UI experience, how to create them, and also setting workspace permissions. So I'll switch over to VS Code. So here I'm simply just running MLflow UI locally, but using basic auth here. And this is your typical MLflow instrumentation that you're used to. Here I'm just specifying the username and password. Obviously don't do this in production, hard coding passwords like that. But we set the tracking URI to my local instance and experiment and start a run. And no surprises there. If I switch over to my browser, here we go. The demo experiment shows up. I think, is the screen share updating to my browser? Or is it still on VS Code? I'll have to change the screen share, I think. Yeah. Okay. Yeah, so no surprises there. It's just the experiment shows up there. And if I switch over to VS Code again, I'll just clear the cache and restart MLflow, but specifying a new flag, enable workspaces. And so when I start that again, I can run the same exact example. I'm not setting a workspace or anything. And then we'll switch over to, so we can click on it. It shows up as you would expect, but if we go back to the home page after reloading, when workspaces are enabled, you have this new landing page where you get to select the workspace that you want. There's also a drop down here to select it. So this is the default experiment, as we talked about. All my existing content that was there previously, still there. So I can go ahead and create a new workspace. Here you can see the default artifact root can be overridden, but I'll just keep it the default. And we can see this new workspace was created. I'll switch back to VS Code. And here it's basically the same thing, except I'm specifying a workspace. So you can set it this way in your code, or you can set the MLflow_workspace environment variable. I'll just run that. Okay, you can see the URL looks a little bit different, where there's this query argument saying workspace equals team A. That's how you get redirected to the correct workspace, but we can see that under team A, my experiment shows up and I can switch between the two. Because I'm an admin right now, I have access to all the workspaces. So I'll quickly show how to create user permissions. So first I'll create a new workspace using the the Python client. And so it's really just as simple as calling create workspace, running your name. You can provide the description, artifact location there. And then those of you who are familiar with the basic auth implementation of MLflow, you can get a client this way, just specifying the tracking URI and also basic auth. Here I've created a user called manage user, and I've assigned it a workspace permission. So it's saying on workspace team B, this user has the manage permission. And similarly, I created a read user that has access to the team A workspace and has read permission. So I'll switch over and I'll just do an incognito so I can change users. So when I log in, this manage user was only assigned permission to manage team B. And so that's all they have access to, but as you expect, because they have the manage permission, they can create experiments. And then I'll just open up a new window and I'll do the read user. This user has just read access to the team A workspace. So we can see, it can see the experiments, but it's not able to create an experiment. All right, I'll switch back to the slides now. So we saw the usefulness of workspaces. Hopefully that means gone are the days of the really long experiments list that you keep on scrolling down. But there's more. So if what you saw isn't customized enough to your enterprise needs, Workspaces has a simple plugin architecture that you can map MLflow Workspaces to any other entity, simply just implementing a base class in Python. So in my particular case, I work in the Kubeflow community, very Kubernetes oriented. So I wrote a MLflow Workspace Provider plugin that maps Kubernetes namespaces to MLflow Workspaces. But you could use this for any other case. Additionally, if you need to customize the artifact root logic per workspace, you can do that in the plugin, or you can just rely on the defaults. And then for very advanced cases around artifact storage per workspace, you can define a new method for workspace on the artifact repository class, and it returns a workspace scoped instance. And so this could be used if MLflow is serving artifacts. You could potentially have different S3 buckets being used per workspace, but the user is unaware of that. They're just interacting with the MLflow artifact server. So from the demo, it might not seem like it was a lot of work, but trust me, it was tens of thousands of lines of code. And I really want to thank Yuki's support for all the PR reviews and bearing with me on contributing this over several months. And I did want to give a shout out to Gage, who contributed the awesome UI experience that you saw for Workspaces. He's a colleague of mine and also in the Kubeflow community. Thank you.
Thank you, Matt. That was actually really good. I really like the whole idea that we now actually have one more layer that gives us more granularity, where, as you say, if I create 1,000 experiments, I don't have to scroll through the list. I can actually create workspace directory. It kind of sounds like a directory file system. Now you actually have one more layer, and you can somehow arrange those in that particular manner. Great. Now we're actually going to switch over to Samraj, who's going to tell us all about multi-turn evaluation, an important feature. And people who are writing chatbots, they would really love this. All right, go ahead, Samraj.
All right. Hey, everyone. My name is Samraj. I'm an engineer on MLflow, and I'm here to talk to you guys today about some of the recent features we released for multi-turn evaluation. So to set some context about what even is multi-turn, why do we need to do multi-turn evaluation? So imagine you have an agent right? I send a message to the agent responds back. That's a single turn. Now, if I go and send another message and the agent responds back again, you have multiple turns, hence multi-turn. And so this pattern is extremely common. And as Jules mentioned, pretty much every chatbot is a multi-turn agent. And in general, a lot of use cases are multi-turn. So why is it important that we have multi-turn evaluation? Well, historically, MLflow has provided a lot of tools to help you gauge the quality of your Gen AI applications, but at a single turn level. But an agent can ace every single turn metric you throw at it, but still leave the user unhappy at the end of the conversation. Take, for example, a situation in which a user asks a question, the agent responds with something, but it's not really satisfactory to the user. So the user asks the same question again, and the agent responds with something maybe not the best. And then the user asks the question a third time, still gets a half okay answer, and then the user just leaves. At the single turn level, each of these interactions actually looks pretty good. Like the user asks a question, the agent responds, it's usually good enough. But at a multi-turn level or a conversational level, you can actually see some form of frustration in that the user is just asking the same question over and over, and the agent's failing to satisfy the user. So in this release, we've introduced a lot of features to help you detect issues at the conversational level and make sure that you're able to improve your agents systematically with the conversational perspective in mind. So the first question is, how do I actually get conversations or sessions in MLflow? And the first step starts with tracing. When you have a tracing decorator, such as what's shown on the screen, all you need to do is add this metadata into your trace, and you'll get essentially the entire sessions UI in MLflow, which looks something like this. So you can kind of see all the different turns in a session. You can see each of the traces that back each of the turns, as well as this like sort of table view of the sessions. You can see session level assessments, which are essentially assessments for the entire conversation, as well as trace level assessments, which are, again, as before, the assessments on individual traces, but then they get aggregated across the session. And so the next sort of question is, once I have my traces instrumented with the session and I'm able to see that in the MLflow UIs, now I kind of want to gauge the quality of my existing conversations or just conversations in MLflow. And so there are a few main ways to do that. One of those ways is to evaluate existing conversations. And if you've seen the MLflow evaluation syntax before, this should look very, very familiar. Here we're essentially just getting the traces in the experiment and passing them into MLflow Gen AI Evaluate with some of the new session level scores that we've introduced, like conversational completeness and user frustration. And what this does under the hood is it actually groups the traces based on that session ID metadata and runs the scores for each of those conversations or sessions. And once you run evaluation, it'll look something like this, where you essentially have a row being your session, and you can see the individual turns expanded out. And on the right-hand side, you can actually see the assessments. So you can see conversational completeness. You can see a trace level assessment, safety, which is actually computed on each and every single trace or turn. And then user frustration, which is, again, a conversational level metric. So this is one of the ways in which we evaluate quality, specifically for existing conversations or traces in your experiment. And we support a bunch of judges to help you do these evaluations. So I showed you conversational completeness and user frustration, but we have a whole bunch more, like rule adherence, conversational guidelines, and we've introduced more scores from third-party sources like DeepEval and Ragas, which include the multi-turn scores. And of course, there are much, much more, but also we allow for customization of conversational judges. So one way to do that is in conversational guidelines. This is very similar to our existing guidelines judge, where you just need to define your judge as a natural language assertion. So in this case, I'm just making sure the assistant has a calm or helpful tone. So this is a really easy way to define guidelines over your entire conversation. You can also use the make judge interface, which we've shown before with this new parameter conversation. And this is a more flexible and powerful way to describe a conversational judge. So whichever way you want it, there is a way to create a judge for your use case at the session level as well. And another important thing that you can do now is actually automatically evaluate traces with session level scores. And so if you attended the last webinar, you might have seen this flow before of creating judges. And in this case, I've actually created a session level judge. I'm actually previewing the result of that judge. But all I need to do is enable automatic evaluation, which is just a flip of the switch. And as traces or sessions flow into your experiment, you will get assessments automatically populated. So here you can see I apparently have a very bad agent, and my automatic evaluation is running metrics that help me catch issues. And the next important mode, so I talked to you guys about how I can evaluate existing sessions, but the next important sort of mode of conversational or multi-turn evaluation is how do I compare conversations as I'm iterating on my agent. So imagine I have an agent, version 0, which is pretty bad, it has a lot of bugs in it. And I fix that agent, I make version 1, but I want to make sure that I've systematically improved my agent. I haven't regressed anywhere, or I haven't introduced more bugs. And so this question of how do I compare conversations across agent version comes up because the trajectory of agent 0 on a conversation can be really, really different than the trajectory of agent 1. For instance, imagine I ask my agent, what's the weather? And version 0 has a bug in the weather tool. So it tells me, hey, sorry, I can't get the weather for you. I might say, why can't you get the error or the weather? And it says, I encountered an error. That's version 0, but version 1, which has the fix, might just tell me, hey, it's 65 and sunny. So these trajectories are very different because my agent has changed under the hood, but I still need to be able to compare the two conversations. And so for this, we've introduced the conversation simulator. And this alleviates one problem, which is actually comparing across conversations that might have really different trajectories. And the way that we do this is by ensuring that there's a shared goal to the conversation. So a goal might be like something like get the weather today, or it could be, as it's shown here, get help migrating data from Postgres to data store. The other big pain that this alleviates is that when comparing across agent versions, I don't want to have to go and interact with the agent every single time to generate new conversations for every agent version, and then for every single scenario that I want to test. That's incredibly tedious. So this conversation simulator helps simulate or create a simulated user that goes and interacts with your agent for you. And this is a really powerful way to automatically generate conversations, to test different scenarios. It's somewhat akin to red teaming. And so the syntax here is really simple. I've just defined test cases with a goal, and there's more stuff that I can customize with that I'll talk about a little bit later. But once I have these test cases, I pass it into my conversation simulator, and I tell my simulator what agent it should talk to in the predict function, and it can simulate a bunch of conversations for me. So I'll show you how this is used in evaluation, but I also want to prefix this with the fact that conversation simulation is still a really new area. It's an open research problem. And so we worked very closely with our research team to develop this method, as well as a couple of the other SDKs that I'll show later on. But chances are it still might not work for you. And so in spirit of keeping everything configurable in MLflow, The simulator is also highly configurable and an easily extendable interface. So you'll be able to create your own custom simulator really easily. So now talking about how we do evaluation with these new simulated conversations, the snippet that you see here is, again, really similar to what you might have seen if you've used evaluation previously. You pass in your predict function, which is your agent. You pass in your scores. So you saw the session level score, user frustration, and a trace level score, safety. But the new thing here is you're passing in the simulator as your data. And again, the simulator has your test cases. But when you pass it in here, what happens is essentially we generate these conversations using those test cases and your agent, and then score the conversations using the scores that you've passed in. And this is, again, really powerful for comparing across different agent versions. So if I have version 0 and version 1, I can actually compare evaluation results and see how much I've improved on certain scores or judges. So here you see that comparison UI where I have in each row 2 different sessions. They have the same goal, the same persona. So I'm pretty confident they're trying to do or achieve the same thing. But I can actually see on the right-hand side that the conversational completeness has actually gone up 50% with my new iteration, and user frustration has actually dropped 75% with my new iteration. So in this way, I can actually systematically verify that my change has actually improved my agent. Now, I alluded to this earlier, but there's a lot of different ways that I can customize these test cases. Goal is the only required thing. It's what the conversation is trying to accomplish. But you can also use persona, which is a way to kind of give the simulator a personality. So maybe it could be a really impatient user that doesn't like giving details, or it could be a really aloof user that doesn't know anything and just creates more questions than answers. Simulation guidelines is a way to really steer that conversation. So you can do things like, hey, in the first turn, don't actually mention that I want the weather in Fahrenheit, but in the second turn, clarify that I want it in Fahrenheit instead of Celsius. And so this helps kind of keep conversations as realistic as possible and as controllable as possible. There's also context, which is essentially stuff you can just pass directly to your agent, and expectations, which, similar to the singleton scenario, are just ground truths for your conversations. And although it's possible to go and write all these test cases out, you may also find that it's pretty tedious and you just want to take a couple of existing conversations that are already in your experiment and turn them into test cases. And so we provided a generate test cases SDK for that, which essentially allows you to pull sessions from your experiment and turn them into the test cases that you just saw. And lastly, you can also persist these test cases in MLflow datasets. So these snippets show you how to create the dataset, merge in the test cases, and then use those test cases or that dataset in the conversation simulator. So that's all I have. I know I've thrown a lot of stuff out there and there's a lot of new concepts. So definitely check out the blog post, which details a lot of this in a practical scenario and hopefully can help solidify some of these concepts. But that's all I had. Thank you so much.
Thank you, Samaraj. Wonderful new particular feature. Yes, you can check out this particular blog post that was actually posted today, and there's a QR code there too, so you can just scan it. I would like to have all the great speakers who shared the fun stuff with the community today to be on camera, so we can start asking questions and addressing them. Let me just go through quickly. A couple of things actually popped into my mind when I was listening to you, Yuki, which was, I really like the whole idea behind having this particular demo experiment that you can just go in there and then share that with the community and show them all the salient features that we do each and every release. I was just curious to understand what was that was actually generating data? Did you actually have an agent that was generating the data, or was it something that you actually had to simulate to generate the traces and all that? Can you guys give us some insight into the internal workings of how the data was generated? One question. The second follow-up question would be, if there was a new feature added, say for example, Samrad's stuff or workspace stuff, how would you actually have to change the agent to incorporate that? Because this is going to be a demo, as you pointed out, that's going to be evolving with every release. So could you give us some insight into the design process and how we're going to address that? Thank you.
Sure. So yeah, that's a great question. So for first part, the demo data currently is generated kind of statically. So we have a like set of like here the traces we want to generate. Here's the data set. Here's the evaluation run. We actually run the evaluation real, but with a kind of deterministic evaluation scholars. So yeah, it's just a pretty lightweight process. Right now you can just click and you don't pay anything, but just pops up in a 2 or 3 seconds. And for the second question of how we update it in the new release, that's a kind of homework on us. So we need to we will maintain the demo generation script up to date for every new major features and make sure keep things added. And if you find any your favorite feature or any feature you're interested in not in the demo experiment, feel free to create a feature request and we will address it quickly. So we will do the best effort to make sure that every new feature, of course, there are like tens or hundreds of features, so we cannot cover everything, but we do our best effort to.
I mean, all the great features that we talked about today. For example, Workspace is a great feature to be able to show how you can isolate things. And then, for example, Tomu's way of the gateway tracking is another feature that people would actually want to. Which actually leads me to Tomu, the question: if you think about observability and how AI gateway fits into the grand scheme of things. If you look at observability, there's sort of 4 categories or 4 entities that you can define observability with. One is compliance and audit. Is it really following the rules that I actually have? Is it operational? Is it really running well in terms of my observability? The other one is cost. Is it really costing me a lot, which I actually alluded to by having the little box, the user tracking or cost tracking. And then the quality is it delivering what I expected to? I gathered from the AI gateway that addressed the operational, the cost, and the quality, because you can actually see what's going in, what's going out. You can actually go through the cost analysis to see how much it's actually costing me. You can provide user groups that say, if your cost goes at a certain point, you're doing some rate limiting and all that. How are we dealing with, how can I use the compliance, the gateway for compliance? In terms, can we do that using the guardrails that you provided? Can you talk something about how would I actually use the gateway to imply certain rules? Guidelines would be one of them.
Okay, yeah, sure. That's a good question. So first of all, as we mentioned, guardrail is one way. We haven't shipped guardrails in 3.10, but this is something we are actively working on. So in the upcoming release, I think we can provide guardrails so that you can actually first compliance, or you can provide like a rejects unsafe information, or you can provide rejects PII information when you use their AI gateway. So that's one way. The other way is just like as I mentioned, in MLflow AI gateway, we basically like store their AI gateway traffic logs as MLflow traces. Then we already have bunch of feature for evaluation, which is integrated with tracing, right? So because we have this integration, you can actually go to their experiment tab to enable the online evaluation for your gateway traces, so that you can actually see their evaluation score, which can be compliance, which can be like a safeness, which can be like a completeness, whatever. You can define evaluation metrics like judges and enable it for in the experiment tab, which is linked to their gateway endpoint, so that you can actually observe the quality of your language model usage. So that's the other way. So okay, again, to summarize, so you could do guardrails if we ship guardrails, which is we are actually working on, and you can also use the judge feature integrated with tracing.
Okay. So the guide rail sort of provides you a way to filter out any input prompts that are actually coming in that could actually have, say, injection by violating that, and the output response would actually somehow the output guardrails would detect if the response is rude or if it's something malicious or unsafe, and that way you can sort of prevent that from going bad. I like that. There's a question regarding the gateway from the audience. Alamat, who's saying, is trying to figure out, does Olama provide open compatible endpoint? I need confirmation of that. But his question is, AI Gateway, wondering if it will work with Olama. So as a provider, are we actually providing that?
Yeah. We basically support any provider which is supported by LightNM. So Olama is one of them. So I think like if you go to our MLflow AI Gateway page and go to the select works of the providers, you can find Olama.
Okay. So Olama is actually supported. So the answer was actually a question. Matt, I had a question for you about the organization of the workspaces. I did like the demo that if it was very backward compatible. So if I started with an experiment and I had no clue about what experiments are, what workspaces are, and so now I actually have the experiments and I enable the workspace, everything goes in by default. One thing I noticed that when you were assigning permissions and when you were giving admin users and users to say, okay, this person can actually assign essentially roles, you were doing that programmatically. So I was wondering if there's a GUI that's going to be available as well, where you can actually go in and give access control to, here are the users for my MLflow. They can actually create an experiment, they can create a workspace, and so on and so forth. Or is that done programmatically or through CLI?
I think right now we're thinking the Python client, just because it's more the admin persona assigning these permissions. Although I forgot to mention, if you have managed permission in a workspace, you can grant other users permission that same workspace. So I think if it's asked for the community, create an RFE, we're happy to do it.
Mm-hmm, mm-hmm. And does the workspace depends on the backend SQL store, or if I was using the file store, I can't really use workspaces. I have to somehow migrate to the SQLite or the backend store first before I can use workspace. Is that a dependency there?
That's right. Yeah, the only backend stores that support workspaces right now are the SQL-based stores. You can add it, but yeah, those are the only ones that support it right now.
Mm-hmm. And Yuki, from what I understand from our roadmap, we do actually have a migration tool, so people who are actually using all ML runs can migrate very easily to SQL backend store or whatever the SQL compatible backend store they use. And then once they've done that, they can use the new feature for the workspace. Is that correct?
Yes,
that's right.
Okay, lovely. Question for you, Samraj. I don't see anything over here, but I have some notes that I just love, because you and I wrote that particular blog on DPVal, and I just love multi-turn conversation. One thing I noticed that when you were actually showing the multi-turn conversation, I was unclear on one thing. You had a whole bunch of sessions, and does the multi-conversation take all the sessions and judges them one at a time, or you actually take one session at a time and then does all the evaluation?
Yeah, good question, Jules. So the session will consist of multiple traces, right?
Yes.
And you have multiple sessions as well that you want to judge.
Right.
A session level scorer will go through each of the sessions and score them, whereas the trace level judges will go through every single trace and evaluate them. So with both, you kind of have sort of that evaluation.
Yeah, I got the distinction between session level traces, which comprises of a group of traces that you're going to evaluate using session judges. Traces are independent. If they're not grouped in a session, I can evaluate the session. What about if I actually, can you think of a scenario where I might have sessions which actually can be grouped together and somehow evaluated in one go, or that is not a use case that you envision?
Oh, like multiple conversations or sessions?
Yes, multiple conversations, by different users, but they are each actually has its own session. So I have a session that I'm talking with Matt about workspaces. I have a session that I'm talking about Tomuru that deals with gateway. I'm talking to Yuki about demo, and I'm talking to myself because I'm crazy, and I'm talking to you about conversations. But now they're all different sessions and each actually have the traces. Can I go ahead and use my scores that I say across everything in one go? Or do I have to select, here's my session, go ahead and evaluate. Here's my second session, go ahead and evaluate. Here's my session with Yuki, go ahead and evaluate.
I see. That makes sense. Yeah, great question. I think the best way to do this is just to create a data set. And so you can, the same way that you do it for single turn or for traces, you can create data sets for sessions, just including all of the traces in that session. And you can, again, use that in the same exact syntax with MLflow GenAI Evaluate. And that way you get that group of sessions that you can keep on using for evaluation.
And last but not least, just to make sure that I'm not ignoring anybody from the audience. Okay, last but not least, the question. I have the mic, so I'm not going to drop it. When you are generating the evaluation data set, one of the things you mentioned about the ground truth. Now, when you invoke the SDK called generate test cases, and you provide the goal and you provide the expectation, where does the ground truth come into play? Does it actually generate the ground truth on the fly, or you actually have to have the ground truth associated with the test case that you are going to do that? Which means that for every test case that I generate, I, as a human being, or I, as an agent developer, would have to manually create the test case?
Yeah, good question.
I mean, ground truth, that's what I mean.
Yeah. I think ground truths are, they're typically very high quality inputs provided by users. And so we try not to generate them as much as possible. And so the generate test cases method will generate everything else. It'll generate a goal, it'll generate a persona, it'll generate those simulation guidelines, but we won't generate the ground truths for you. That's something that we expect from the user.
Yes, brilliant. Well, on that note, thanks a lot, all of you, for sharing all the great stuff that we actually have shipped with 3.10, and looking forward to more stuff. Thank you all for joining us. We had people from Papua New Guinea all the way to Finland, Helsinki, all the way down to India. So we actually had a global community who actually joined us, and hope to see you again for 3.11, Yuki, 3 or 4 weeks from now.